what's up, Gurleen? Ready for lecture. Classes. It's gonna be fun. It's weird that going live doesn't, like when I'm on the live tab of the YouTube channel, it doesn't show up with the new live. You have to go back to the main channel. I don't know why they would design it like that. If I'm on the live tab, seems like an indication that I'm interested in watching live broadcasts. But, oh well. Set rating in the constructor. That's the one I want to talk about. Otherwise, we're just waiting for lecture. Oh, I should do my countdown timer. Lecture starts in... countdown timer. Sure. 3... What's up, Aiden? YouTube's weird sometimes. They've been doing this forever. You'd think they'd figure it out. They have teams of the smartest people on the planet. They hire the most brilliant software engineers and give them tons of money. You think they could figure out that if I'm on the live tab, I want to watch live broadcasts. But I don't know. YouTube does some weird... Google in general does some weird things. I think they hire people who are... This is my opinion. But I think they hire people who are too smart for their own good. They're great at algorithms and stuff. And if you're practice for the coding interview, you know that it's all about algorithms and runtime and efficiency and data structures and everything. There's nothing in their interview or the hiring process that says, do you understand how humans work? Do you understand what a human being thinks when they sit down to use a piece of software? It's just not part of what they do, and it shows. I think anyone who works on an app like that should be forced to use their own software. They'll learn a lot by doing that. And I'll keep that rant pretty short. Because I still do love their products. They make the best stuff. I mean, I have complaints about Google, but what's the alternative? Nobody else out there is even trying to make anything good. So I can't complain too much. Not no one, but... You know, any Microsoft product just seems like they wrote some random code until something kind of half worked and just shipped it. Apple used to be better, but they're losing their ways as well. Google used to be fantastic, but they're losing their ways. Or maybe I just expect too much from my software. I don't know. That's why I'll train you. How did my volume tick up? I didn't touch any volume button. Okay, is this really sensitive? Oh, that's pretty sensitive. Everyone's just getting lazy. I think profits are driving decisions more than building cool tech these days. I think that's the bigger problem. Which does, in turn, make people lazy. Michael, what's up? Morning. Which does make people lazy. Like, if you're... if you're a developer working at a company like that and you realize that profits are driving things, you're going to not necessarily be more lazy, but you're gonna not be as motivated to do a good job. I think that's more so what's happening across the industry, especially when there's layoffs now. All right, but lecture starting. Enough of that talk. So we had this poll of whether we should have a break or not. The Despite the wording, I did want a break, so it's not allowing me to have a break. I don't want a break. I just want to plow through and go through lecture. I never know what to do during a break. I'll take like a minute to catch my breath, and I don't know. But anyway, the votes are in. We're gonna not take a break on the schedule, and I have to cheat again. I always have to look at my whiteboard. 11 to 12:30 and 12:40 to 1:40 is the official timing according to the hub. So whether we should actually take that 10-minute break or not, the results are in. We're not taking that break. It's not even up to Gurleen. She doesn't get to decide. So we're not taking the break. Since we're not taking the break, I'm not going to, which I did my math wrong on the first two lectures. Since we're not taking the break, I will end 10 minutes before the end time. So I'll just collapse those two sections, which is technically lecture and lab, but they don't give me enough time in the week to do labs. So it all has to be lecture. But I'll collapse those together, so we'll end at 2:30 is going to be our end time. So last week I was doing the math wrong. I thought without the break, with the extra 10 minutes, it would be exactly as much time as a week of lectures. I don't know how I did my math so wrong. Like, it's so obviously not the case. But if we go 11 to 2:30, that's exactly 3 50-minute lectures, like would be a regular semester. And that's the material that I'm using for each lecture is 1 week's worth of content. So ending at 2:30, going from 11 to 2:30 with no break, that's exactly the same amount of time I would have in 1 week. So I'll be ending at 2:30 is the short of that, instead of basically stealing 10 minutes of time by not taking a break and also ending at the same ending time. Doesn't really make sense. So I had my timing off last week, but we got this. We're in rhythm now. We're in this thing. We're in it for the long haul of 6 weeks. So with that, let's start talking about content. So this is, I did want to mention, just very briefly mention, the content, just because we're still getting into it a little bit still. This content is going to be everything you need to do programming task 2. You should be well on your way to completing programming task 1 or done with it. The expected deadline is, because I'm used to these being 1 week, so I'm like, it's this week. Why isn't it on here? Is Thursday before next lecture on Thursday at 9 a.m. That's the expected deadline if you're trying to get those AOs and work your way towards an A in the course. Then by Thursday, you need to be completely done with programming task 1. You should at least be well on your way to completing it. Don't put it off to the last minute and try to do it all tomorrow. Maybe you get away with that with tasks 1, 2, and 3. Do not make a habit of that, because you will not get away with it on task 4 and onward. Those tasks, there is a spike up in difficulty when we get to programming task 4. It does get a little more difficult. So don't get in that habit. But everything we covered today, you can do programming task 2. So after today's lecture, if you're done with programming task 1, get started on programming task 2. So that's where we're at in terms of assessment. And then 1 week from today is our first lab quiz. I'll talk about that more Thursday, or not. I might not talk about it. But we'll have our first lab quiz on Thursday. I'll at least have to figure out the logistics and share what the exact logistics are going to be. I'm leaning towards just sending an email at 11 o'clock with the link to the thing. I don't see a reason to go live on YouTube. We could all hop in a Zoom meeting, but I don't know. I'm not too fond of that idea either. I don't know what we gain by all being in a meeting together. So I might just email the link and then go live at noon. Start lecture at noon. Or maybe 12:10, give you 10 minutes to cool down after the quiz. We'll see. Can I increase the microphone volume? So I did turn it kind of choppy in the last lecture. Is that better? Oh, and I did put the latency back to normal, so it's going to be a little tougher to get feedback on this because I got to wait a few seconds for it to make it to the live. because I can't adjust that. Here, I'll adjust it one more time. I'll put it right here. I'll adjust on my mic and on OBS. So if that's too quiet or if the audio is garbage quality, let me know. Or if it's just not perfect quality. I would like to get my audio perfect. I spent money on a nice mic. No, not really. Oh, I forgot what I asked. Oh, shit. A little louder, please. Okay, how about this? Okay, my question was, how about this? I have to remember that. A bit better now. Is it still too quiet, though? I didn't adjust it. I'm back to lecture 2. Much better, okay. As long as the audio, I can't hear the audio of the stream as I'm streaming. So I don't want to get to the territory where it's going to be crappy quality, is my only concern. So as long as it's good enough you can hear me and it's not crappy quality. Better or perfect? Yeah, the delay is the tough part. I'm trying to remember which question I asked, factor in the delay, and then figure out what you're answering. Okay, better, and then I asked better or perfect, and then in a few seconds I should get those answers. Yeah, there's going to be chat lag. Yeah, I'm normal latency. I went to low latency last lecture, but there were a few times where it was buffering, so I wanted to get away from that. All right, 6 minutes of intro stuff and announcements. Let's get on with it. Objects and classes. I don't want to take up too much time with the intro. I sometimes have a bad habit of talking about off-topic stuff at the beginning. So let's not do that too much. All right, so when we talked about array lists, recall that this worked a little bit different. Perfect, yes. That's what we strive for here. All right, so when we talked about array lists, we saw that array lists did go on the heap and that they behaved a little bit differently. We had references, memory allocation on the heap. We had this new keyword, and I mentioned very briefly something called a constructor. Actually, I might have not even mentioned it on Thursday. But today we're going to talk about all those things and make sense of what the hell is actually happening during all of this and go into all of the detail of what this means. New array list. What's going on with this? And we are going to take a peek into the array list class itself and look at how an array list works. So in this example, well, I kind of already said all this, but we created a new array list. That array list went on the heap. In a variable of type array list, that variable doesn't store an array list. It just stores a reference to an array list, which are the instructions of where to find that array list on the heap. So this is where we can find an array list on the heap, and that's all that's stored in R1. That's all that's stored in the variable, not the array list itself, the location of where to find the array list. And then we use the dot operator to be able to access that object on the heap. So R1 stores a reference, not an array list, so we can't really do anything with the values stored in this variable, but we can use the dot operator, which means, hey, I know you store a reference. I don't care about the reference itself, but just take me to the object to which your reference refers. So after we pass this dot, now we're no longer at the reference, we're at the object on the heap that's being referred to. So after the dot, we're over here on the heap because we followed the reference to this object. And then everything we do after the dot is at that object. So add 10 minus x happened at this object, not on the stack at this reference. Before the dot, we were working with the reference itself. And that's important to know. References is probably the most, maybe not the most, I don't know, probably the most, I think the most confusing part of objects and classes. So that's the part I'll spend a lot of time talking about. And I'll give a warning up front, my lecturing style, kind of how I like to introduce new topics is right up front. I like to dump all of the theory, the content, the concepts, all of that stuff right away. I like to get all of that out there and then spend a lot of time going over examples that'll reinforce that content. So these first slides are going to, the first like 15 or 20 slides even, are going to talk all about what objects and classes are. And then for the last like hour and a half of lecture, we're going to go through memory diagrams and show examples of how exactly this stuff works and why we care about this stuff. That's really like, it's one thing for me to sit here and talk to you about references. It's another thing to say, this is why we actually care. When we're writing our code, this is how our code behaves differently because these are references instead of these variables actually storing array lists. Because they store references, our code will behave differently than they would if they stored the array lists themselves. So let's get into it. So array list is a type, which means it's defined by a class. In Java, every type has a class, aside from our primitive types. Int doesn't have a class associated with it, but any type that starts with a capital letter has a class associated with it. So if we're saying new array list or new hash map, there better be a file called arraylist.java in a package named java.util, in a directory named java.util, in some package, in this package, in some library, I mean. That's a nuance we don't have to get into. There's better be a file named arraylist.java with code that defines a class named arraylist. That has to exist. And if you go into IntelliJ and you control click, so hold control and mouse click on the name, I would do that right here on my array list, it'll take you to that code. It'll actually take you to the code that defines an array list. There's no magic with built-in classes like array list and string. You can find the code. You can just go to the code in IntelliJ and see exactly what's in there, how they're defined, how Java works internally. You can see all that stuff. It's not always super useful. I'm going to use it here as an educational tool. But if there is a situation, actually I shouldn't say that it's not super useful. It is useful. For example, if you want to know what methods are contained in the string class, like what are all the things? You have a string and you want to do dot something. What are all the somethings that you can do with that string? Well, you can go to the code and look at all of the methods that are defined in the string class and see absolutely every single thing, a complete comprehensive list of methods that you can call on a string object. So it is useful in that sense. You can do .size, .split. I don't know what else would be common to use in a string. 2 uppercase, 2 lowercase, equals we saw last lecture. But what other methods are there? What's every possible method? You can just go to the code and see it. So there's a class named ArrayList, and that defines the ArrayList class that we create ArrayList objects from. And I'm not going to show the whole code. I'm going to just show bits and pieces of the code. If you're interested, go to it yourself. You can see all of the ArrayList code. I tried to keep out most of the irrelevant bits, but there's quite a bit in there, so I cut down most of it, or else I could spend a whole lecture or two just talking about how ArrayList works. So when we use the keyword new, that's going to create a new object of that type, in this case ArrayList. That's going to create a new ArrayList. It's going to return a reference to that ArrayList. It's going to create the ArrayList on the heap. It's going to do all that, and we saw that in the last lecture. How it actually does that is by calling a method, a special method called a constructor. So in the ArrayList class, we can define a constructor with a very specific syntax. The name of the method is going to match the name of the class. So I have a method named ArrayList, and then I don't give it a return type, because the return type is going to be a reference of type ArrayList. We don't have to type that. We don't have to be redundant. Java's just like, look, you're creating a constructor because you named it ArrayList. I know your return type's going to be a reference of type ArrayList. And these methods are not static. So we're going to see a lot of non-static methods moving forward, where we'll see it crop up a few times throughout the rest of the semester, but we're mostly done with static methods now that we're going to start talking about classes and objects. We're going to have lots and lots of non-static methods. So no static, no return type, name matches the name of the class, and you got yourself a constructor. So when you say new ArrayList, we have this empty parameter list here because this is actually a method call. You're calling a method, you need, argument list. You're calling a method, you need an argument list. We're calling a constructor that takes no parameters, so we give an empty argument list. And we have the type parameter. We talked about that briefly last time. On Thursday, we're going to talk about that in a big way. We're going to create a class that takes a generic type, namely a linked list. But for now, we can ignore anything in angle brackets. This E up here, this type here, it has to be there, but just know that we are passing this a type of integer, and E will be replaced by integer. But I'll have a much longer conversation about that on Thursday. We have enough stuff to talk about today. So plenty of new concepts today. We don't have to get bogged down on generic types quite yet. And you can, this is something you can do in Java. You can't do this in every language, but you can do this in Java, is have multiple methods with the same name and the same return type. This is allowed. We can have two constructors with the same exact name, or any two methods with the same name. I'll have a few examples of this today. And this is called overloading the method. So we have two different definitions, and which method is called when you call a method with this name depends on which arguments you give it. So if you give it no arguments, you get this constructor. If you give it a collection that extends E, we don't need to get bogged down on the syntax here. But if you give this a data structure of the type matching this array list, then it's going to call this constructor. So based on your argument list, it's going to call the method that with a parameter list that matches the argument list that you gave. So it can have the same name, same return type, but they have to have different and unique argument lists or parameter lists. And then you choose which one to call by giving them different argument lists. So a useful thing in Java, method overloading, multiple methods with the same name, but different parameter lists. That's the only thing that changes. And there's a lot of code in this constructor. I removed all the code for the slide because there's a lot there, and it doesn't really have anything to do with what we're talking about. And this is a very convenient way to create an array list. I've been getting this question quite a bit. I get it every semester. I should probably put this right in the array list slides and have an example right there to get this out there. But if you want to create an array list in one line, when you're testing your average method is the first time that it comes up, you can use this syntax, arrays.asList, and then list all of your values in that method call, and then put that in the constructor call of your array list constructor, and then that will call this second constructor, which pre-populates the array list with the values in the data structure that you gave it. If you're doing this, don't forget to import arrays. It's in the same package as array list, but does have to be imported separately. So call import arrays.asList. This is a static method in the arrays class, and then call that method through the class. And then this will create an array list with the values 10, 9, 8, 7 pre-populated in it. Otherwise, you would have to call the default constructor with no arguments, and then call r1.add 10, r1.add 9, r1.add 8. We did that in a loop last time, but if you're creating your test cases for the average method, that gets tedious. We would rather just create our array list and populate it in a single line. Just keeps your test cases nice and clean, nice and compact, easier to read. But if you don't have arrays.asList, if you just do new array list of 10, 9, 8, 7, Java just doesn't do that. I wish it would. I wish they would just add that method. I see why they don't, because it would conflict with this method, so they can't really change that now, to be fair. But the way overloading works, it wouldn't be able to tell which one to call. But and it just wouldn't compile. But I wish they did that from the beginning, but they didn't. So we have to add arrays.asList. It's not that big of a deal, but this is how we can create it in one line. All right. Objects have both state and behavior. This is one of the probably biggest takeaways of this lecture. What is an object? Because so far we're talking about classes. I was mentioning objects, sure, but When we have an object, which we're going to use classes to create objects, we're using the ArrayList class to create new objects using the new keyword. An object is a container for two things: state and behavior. State are going to be variables that are associated with that object. In this case, we have an array, a plain array called element data. So this is a variable that's associated with each object of type ArrayList. Every time you say new ArrayList, you get a variable named element data of type array of object and a variable named size of type int. And those two variables are part of that object. You also get and we call these instance variables. These are instance variables. They're associated with an instance of the class, which we call an object. It's one of the things where there's a lot of like redundant terminology. Is it an object? Is it an instance of a class? Is it? Oh, I'm blanking on the other ones. These variables, are they called instance variables? Are they called fields? Are they called state variables? Are they called object variables? There's so many different names for all these things. For these variables, this semester, I'm going to stick with instance variables. They're associated with instances of the class. And then the instances of the class will be objects. Those are objects. You instantiate an object from a class. So a lot of vocab out there. A lot of it kind of means the same thing. It's one of them things you just kind of got to get used to. But there's a lot of vocab around this. But objects contain state in the form of variables and behavior in the form of methods. So an object is a container that stores variables and kind of functions. We call them methods when they're part of a class. But if you have a whole bunch of functions and a whole bunch of variables and you want to smash them into one thing, that thing is an object. So that's the reason we use objects, is so we can kind of bundle data in the form of variables or state. I'm complaining about the redundant names, and now I'm using 3 different things to talk about the same thing. The state of an object, variables, data. It's all the same thing, but I'll try to be consistent and try to just stick with one. The state of the object and the behavior of the object. And the behavior can depend on the state. So if you ask an array list for its size, you would expect it to depend on the actual size of that array list. So depending on which elements you're adding to this array list, it's going to change its size, and then the size method is going to behave differently based on the actual size of the array list. So what size returns depends on the state of the array list, how many elements are currently in that array list. And for what it's worth, a few side notes. ArrayList does work with an actual array. ArrayList is basically a wrapper class around a plain old array. And then it uses that array underneath the hood to implement the behavior. And then it adds nice features on top of that array that don't exist in actual arrays. For example, arrays cannot change size. But ArrayList gives you the illusion that they can change size by creating new arrays whenever you run out of space in the old one. A topic for 250. I'll mention that a few times when it's relevant this semester. But 250 will go in much more depth on that idea of an array list with variable size. Actually doesn't have variable size. It just simulates that for our convenience. And when you call the constructor has one main job, is to initialize the state of the object that's being created. So when I call the constructor, I'm saying, hey class, give me an object of your type. I want a new array list. And then the constructor's job is to initialize any values that need to be initialized, namely the element data and the size in this case, but any variables that are part of the state of that object, that new object, need to be initialized. And this can depend on which constructor is being called. So in the case of an array list, if you call it with no elements, no arguments, you get the default constructor with no parameters. And element data gets this default initial array, which is an empty array. which is, I'll talk about these a little bit more, private, static, and final. Oh, actually, I talked about these last lecture. Let's do it right now then. So static means it's associated with the class. Final means it cannot change, and since it can't change, it's effectively a constant. And when we have constants in Java, we type them out in all uppercase for the variable names to communicate to other developers that this is a constant without them having to look at the definition of that variable. So we get the default empty array, and size, we don't initialize size here, but we do get default values in Java. If you declare a variable without assigning it a value, every variable type has a default value. For int, it's 0. So the Java devs said, you know what? We're just going to use that default value. There's no point in assigning size to 0 because it's already got the default value of 0. Nothing to do here. If you call the constructor that takes parameters, it does a lot of stuff here. There's a lot of code here. You're welcome to go look at it if you want. But it initializes, creates an array of the appropriate size, populates it, sets size, does all the things that you would expect it to do to get this array to have all of your data in there, and for size to be the number of elements in that array list that was created. But in general, the constructor's job is to initialize the state of the object. Then we have methods. So any non-static method that's defined in a class is going to be part of the behavior of objects of that type. So every array list that we create in our code is going to have certain methods. These are only some of them. Of course, there's tons of methods. Size, get, and add are the three that can, with those three, we can do pretty much anything we want with an array list, for the most part. Obviously, not everything. We can't remove an element with just these methods. Sometimes we need to do that. But we can do quite a bit with these three, and these are the three that we saw in the slides already. Actually, I don't even know if I showed size. Yeah, I did, because I didn't show the enhanced for loop with an array list. So these methods are going to be the behavior of objects of this type. So whenever I say new array list and store that reference in a variable, I can say, hey, array list that I just created, this reference dot size dot get dot add, because these methods are defined in this class. And we do have an overloaded method here. Here's my second example of an overloaded method. The add method is actually, this is the actual code in the ArrayList class, by the way. This is an overloaded add method where you'll call this method, well, let me explain this backwards. The way an element is added to an array list needs to know the element that's being added, the array that's storing all of the elements, and the current size of the array list, the number of elements in the array list. And then with those three pieces of information, the add method can do its thing and actually add the element into the appropriate location, increase the size. And here's a little bit of code. I won't go in too much depth over it. This is a pet peeve of mine, but you can, if your conditional block is only one line, you can leave out the parentheses. I always add my parentheses anyway, or braces. I always add my braces anyway because I think this can be confusing to read sometimes. And if you want to add a second line here, I've seen devs add a second line to a conditional like this, but that second line, even if you indent it, it's not part of the conditional block because of the way this special syntax works. It's easy to write bugs when you're using this syntax. But anyway, if you run out of space in the underlying array, then it's going to call this grow method, which is part of the class, which is going to create a new array of twice the size, copy all the elements into the new array, and then remove the other array from memory. So that's how it can get around the restriction of the arrays not being able to change size. That's true in all languages, by the way. Arrays can't change size. In any language where it seems like they can, something like this is going on, where you're not dealing with a plain old array, you're dealing with an array, like in JavaScript comes to mind, you're dealing with an array class that has this fancy behavior underneath the hood. You're not dealing directly with your arrays at that point. And so that's what you need to add a method, but we don't want to mess with all that stuff. So the public add method just takes the element that wants to be added and then calls what we call the helper method, calls the helper method add with all of the values that it needs, and then this method is going to actually do the adding. But we expose this public method to the user because that's how I want to add things to an array list. I just want to say, here, add this thing. I don't want to say add this thing to this array that has this many elements. I don't want to have to think about that. So this one is private. It's hidden as an implementation detail, but it's called as a helper method because it helps us write this add method and helps us keep this method cleaner, a cleaner parameter list here. This is a big confusing topic. We'll have plenty of examples. It's what I'll focus a lot on. I said I'd primarily focus on references. This is part of that. This is a special keyword that's going to store, it acts like a variable, and it's going to store a reference to the object that called a particular method. So in all of these methods, we can use this, which is a reference to the calling object. And it's exactly, it's the same as self in Python. If you've done OOP in Python and you've seen self all over the place, this is filling the exact same role. So this is a reference to the calling object. In the case of constructors, it's still a reference to the calling object, but the calling object is the object that's being constructed. That object that doesn't quite exist yet, the one that's being initialized, this is a reference to that object that's being created. And much more about that when we get to the memory diagram. I'll talk about references, including this, because this is all about references. We'll talk about that lots. And the access modifiers. So we're seeing a bunch of private and public on our things. Before, we just saw public everything. I think I pulled out one private at one point, but I didn't really explain it much, because here's our time to explain it. So public versus private. Public means anyone can use this code. Anyone can call it from anywhere. Everything's on the table with this. So that means from outside of the ArrayList class, which anytime you've ever interacted with an ArrayList, with any of this code, you've always been outside of the ArrayList class. So public means you can access this code from anywhere. So you can call this constructor, which you've done before. You can call this constructor, which you may or may not have done, but after this lecture, hopefully you will, to clean up your to make your average method testing the average method in programming task 1 a little cleaner. You'll use this one. You've seen .size, you've seen .get, you've seen .add. We've accessed those, and we're allowed to because they're public. The private ones can only be accessed if you're writing code inside the class in which it's defined. So these private variables can only be accessed from inside the class that they're defined. So outside of these braces that define the ArrayList class, you can't access any of this private stuff at all. Not allowed to. You cannot, no matter, well, you can't access these instance variables from outside the class. You can't say new ArrayList and then my ArrayList dot size without the parentheses. You can't access this variable. You can't do dot element data. Doesn't work. I had to bite my tongue a little bit. I was going to say, no matter how hard you try, you can't access that. Well, you can actually access them, but you have to do something called reflection. It's not relevant to 116, but technically you can access them. So don't use private as a form of security, because everybody can actually access them. There's no security involved with that, but it's a way for us to communicate to other developers that says, hey, don't mess with my stuff. just don't touch these things. So we usually use private if nobody else needs access to it, and especially if they did have access to it, they could mess with our stuff. So for example, if somebody had access to the size variable, they could just change the size variable without actually adding elements or removing elements from element data, and now size would be out of sync with the length of element data, or actually that's It will be out of sync with the length of element data most of the time, actually. But it might be out of sync with the number of elements in element data, which would be bad. They can really break our stuff if size were to be public, for example. So we make them private to communicate, hey, don't mess with my stuff. We also make things private if it's not relevant to any other users. So when you're using an array list, it's not relevant to you that element data and size exists. You don't care. You'll never, I shouldn't say never, but you generally don't care about these variables. You don't care how things work. You just care that they work when you're using somebody else's code. We want to make sure you understand how your code works, but when you're using someone else's code, you just want it to work, and you don't care how. Especially when it comes to this overloaded add method, you'll never have to care that there is an overloaded add method with 3 parameters. You don't have to care about that. So the Java devs say, you know what, let's just make it private. And then when you're in IntelliJ and you do like variable name dot, it'll give you a list of all the things that you can do with that thing, with that object. It's not going to show you any private methods in that list. It's just not going to bog you down with implementation details like that. So we just hide it. We say make it private and hide the details. This is a concept called encapsulation. You're going to hide the details and only expose the relevant parts to other developers. So only the relevant parts are exposed to them, and how you got stuff done, hide all the details. Encapsulation is this idea of hiding the details, hiding all the implementation details, and just exposing the behavior, the top level things that other people want to call. And then the public methods that we expose, this is called our API. This is a term I'll use a few times throughout the semester. I just read my course evals for last semester, and someone who was like, Jesse uses the term API, but he's never talked about he never defined it or anything. I do define it, but it does come and go really fast. Maybe I should highlight it more since I used the term a few times. But if you walk out of 116 without knowing what API is, that's actually pretty fine. That's okay. Which is why I don't emphasize it more. It wouldn't be a question you'd have to answer to be able to pass the class. But I do like explaining what it is. API, our application programming interface, is how different... Oh, let me preface this. Their API, I think, is one of them acronyms that's completely overused. It's very saturated and has many, many, many meanings depending on the specific context. But the most general meaning that I can give it, the most general definition, is it's a way for 2 pieces of code to interact with each other. So how is any other piece of code interacting with an array list? Well, it's going to use its public methods, which is its API. So the API, in our case, when we're talking about classes and objects, our API, how other pieces of code interact with our code when we're defining a class, is going to be all of the public methods. That's how other code is going to interact with us, is the public methods. So we say that this is our public API. This is how other people will interact with us. So that's our application programming interface. It's our API. I feel like I just said API like 10 times. Now you understand APIs because I said it a bunch. It's how code interacts with each other. They can't access our private methods or variables, so they have to interact through our public methods. And finally, static versus non-static. I told you, I warned you, it'd be a whole dump of concepts right away. But this is like everything you need to know about classes and objects. Static is, I believe, the last thing that we're talking about. So static means that thing, I guess it only ever be state or behavior. But that variable or method is part of the class itself. So moving forward, we're mostly going to create classes as a way of creating objects. A class is going to be a factory, or rather a blueprint on how to create an object. So we're going to use our classes to create objects, And then through objects, we're going to call our non-static methods and access our non-static variables. Oh, there is one more concept, getters and setters, speaking of private variables. So anything that's not static is associated with objects of that type, which is mostly what we're going to be concerned with moving forward. Every once in a while, you'll still see a static method or a static variable, and that means that it's associated with the class itself, meaning you don't have to create a new object. You don't have to say new array list to use this variable here because it's static. It belongs to the class, not objects of that class. And then we call static methods using the class name itself. So in your programming task 1, when you're testing your methods, you're doing problem set dot average to be able to call that static method, because the average method belongs to the problem set class, and it's a static method. It's a static method, so it belongs to the class. You call it through the class itself. So ArrayList dot, and then access the value. We're inside the ArrayList class definition, so we're allowed to access this private variable, and we can use it this way. And if you don't have ArrayList dot, this would still work. If you just said default capacity empty element data, that would still work because it's the only variable with this name that's currently in scope. So sometimes you'll see, I swear we just saw one. Oh, the grow method. Nope, that's non-static. But this is the same as self.grow. It's a method that's part of the ArrayList class, but it's a non-static method. That's kind of the same idea, but you don't have to do this dot. This dot is technically optional here. I don't like how these devs mixed, didn't do the optional thing here, but did the optional thing here. Kind of, doesn't matter, but for explaining that point, it makes it a little weird. Or actually, maybe they did that so I had an example of both in one example. So the static variable is accessed through the class itself. And sometimes we have classes that are nothing but static methods and static variables. The math class has nothing but static methods, and in fact, its constructor is actually private. You can't create an instance of the math class because that doesn't make sense. You can't create a math object. It doesn't make sense to do that. It's a collection of static methods and static variables. So we called the one math method we saw so far was ABS, and we called this by saying math.abs. We called it through the class itself because it's a static method that belongs to the math class. So math.abs, so go to the math class and look for a static method named ABS, then take the absolute value of whatever I give it and return that absolute value. Actually, we saw the one with doubles, but with method overloading, there's a version of ABS with doubles as well. And there's actually some useful constants in the math class as well. If you want e, pi, or tau, math.e, math.pi, math.tau will give you those constants to as much precision as a double can allow. That's how much precision we're going to have. Which actually looks a little short. Maybe. I don't know. No, I don't want to think about it. And it does have, I left these in here just because I don't know why these are here. Degrees to radians and radians to degrees. Useful constants to have, but I don't know why they made them private. They could have made these public for us. It would have been fine. Generally, we'll see on the next slide, generally our variables in classes, we want them all to always be private, and we'll hold to that throughout the semester, throughout the class. The only exception to that is if you have a final variable. If it can't change its value anyway, you might want to just make it accessible to everybody. It usually doesn't hurt to do that. E's never going to change. It's constant, so it can be public, and just let everybody say math.e to get that constant. There might be a good reason why degrees to radians and radians to degrees are private, and they're only used inside the math class then, of course, as helpers for the other methods. But yeah, I don't know why those ones are private. So you can't do math.degrees to radians. Okay, I kind of misspoke. It's not part of my intro to classes and objects, but there's one more concept today, which is getters and setters and private variables. All right, I'll stop here for a brief second. That was a lot. Before we start creating our own class. Actually, let me rest on this slide so you can at least take a look at what we're about to do. And any questions on array list? So I use the array list example because it's something you've seen. You've seen new array list, albeit just last lecture. But it's something you've seen, and I wanted to relate that to what we're about to do. So what we're about to do is create our own classes. Our own classes with the intent. We've created our own classes a few times already. But our own classes with the intent of being used to create objects. So we're going to write constructors in non-static state and non-static behavior. That's the big difference today. Oh, it's my phone's falling asleep so fast because I don't have it unlocked. I just want to look at the time. All right. I assume there are no questions. If there are, though, I can always go back. All right. So what we want to do is create a player class with the intention of creating objects of type player. Excuse me. So we want to get to a point where we can say new player and have that create an object on the heap, get a reference to that object stored on the stack, and have that object with state and behavior of their maximum hit points. And I'm thinking a player like a character in a game. A maximum hit points, their current number of hit points, and their name. And we won't quite get to all of this, attack power and players attacking other players. We won't get to all of it. Some of it I was going to do in a later lecture, and I cut a lot of it just because it was too not too much like conceptually, but too much to fit in a lecture. I just ran out of time in the week to get to all of it. We can't do math.degrees to radians because it's private. So what's the purpose if it's not intended to be used? So it's used inside the math class. Like a lot of the trig definitions in the math class itself use those constants. But I don't know why they didn't make it accessible to us as well, because we could have took advantage of that instead of writing our own, doing our own math to generate those constants. I just don't know why they didn't make it accessible. But the Java devs inside the math class do use that. Of course, I cut down most of the code. Math has all kinds of methods, and you can look at all of the... Oh, let me give a demo of that just real quick, actually. So if I do math.e, just something. If I control-click on math, it'll take me to the actual code that defines the math class. And I can take a look at all these values. The private constructor, so I can't say new math. The e, pi, tau, and then private degrees to radians, private radians to degrees. But if we take a look at this, we can right click and go to find usages. It's only used once. Oh, because it's used in 2 radians. So it's used once in the 2 radians method. Oh, so I guess we do have access to that constant in a way, because we can call the public 2 radians method and convert that way. And the 2 degrees, I guess they're only used in 1 method each. So they could be defined in these methods. I guess it's better organization to put them at the top of the file. I don't know if I would design it the same way. Maybe I would. I think I would just make these public, though. Let me get rid of my compiler. But the idea that you can control-click on things. You hold control, and then you click. It'll take you to whatever definition you want to get to. And since we know a little bit, since I'm here, this is a little off topic, but system.out.println, we have a more understanding of this now. System is a class. It has an instance variable that's static named in of type input stream, and then input stream has a method named println somewhere in it. Well, I'm not going to just scroll through code forever. But input stream has a method named printline, and that's what's being called. So you're going to the system class, the out static variable of the system class, and then calling the printline method on that variable, on that object of type print stream or input stream. Sorry, print stream. I went to in instead of out. All right, sidetrack over. Let's get back to some slides. The demo was a big help. Oh, cool. I like a good blend between slides and live coding, but I tend to, there's a lot of stuff to talk about on the slides that I tend to not do as much live coding as I can. So I like to hop over to IntelliJ whenever I have a good reason to. I like to look for reasons to hop over. In some of our live, because the summer session is so short, and I don't have actual lab times, some of the live demos, those are usually the first things to get cut. So some of them did get cut so we can fit the quizzes into lecture time. Just is what it is. All right, so let's define our first class, this player class that's going to track its HP. So there's a few things that we need. If we're going to have instance variables, we're going to have these 3 values that every player object can track. We're going to create those as instance variables. Your instance variables, when you're writing a class, it's any variable that's declared outside of all the methods. So your class is going to be a collection of methods, and then any variables, you can declare variables outside of the methods, and those variables will become instance variables. So any variable out here is going to be created for every single object of this type. So every player that we create, when we say new player, we're creating an object on the heap that's going to have these 3 variables for that specific instance, that specific object. Then we're going to create a constructor, which is going to be a generally public. Of course, we just saw an example of a private constructor with the math class. We're creating these classes for the intent of creating objects, so we want them to be public. So a public method sharing a name with the class. So this method has to be named player. It has to be a capital P if this is a capital P here. It has no return type, and it's not static. In fact, most methods that we create from now on will be non-static, and it's on one of the slides. It might be coming up. But if I ever say write a method and I don't specify whether it should be static or not, that means it's not static. I'll only specify, like in the homework instructions is where this is most relevant. If I say write a method that does XYZ, that means non-static method. If it's static, I'll specify that it's a static method. Write a static method named. That's the only case where it'll actually be static. Other than that, do not make your method static unless the instructions otherwise say so. So we're going to have a constructor, which is the constructor's job is to initialize our instance variables. So we have a few design choices here. One big one is what parameters should our constructor have? And the answer is generally, what do you want? Or the actual question is, what do you want users who are creating objects of this type, what do you want them to be able to initialize? So I want them to be able to choose their own name, and I want them to be able to set their max HP, but it doesn't make sense for me to want to have them or to require them to set their actual HP. Instead, I'm going to set their HP, their initial HP, to their max HP. So every player in this game, we're going to have them spawn in at full HP. Makes sense to me to do that. If somebody wants to do something else, they can change the HP after they spawn in and modify that. For most users, I want them to use this constructor, and we could overload the constructor with a third parameter. There are options we could do. But I want them to initialize these two things, and HP is set to their max HP when they're created. And then the constructor's job is to initialize the instance variables. So our 3 instance variables, we're going to give them values. We do technically get default values here, but we're going to override those defaults with values that make sense for our specific case. And I'll never quiz you on default values, by the way. I know I mentioned that a few times this semester, that int will have a default value of 0, string will have a default value of empty string, double will have a default value of 0.0. I won't test you on those. There won't be a quiz where you have to draw a memory diagram, where you're expected to know what the default values are. It's something we could add to the course, but I just won't do that to you. So you don't have to worry about the default values. We're going to initialize the values when we call the constructor. And you wouldn't write the default values in your memory diagram and then cross them out. If you do, I'm happy to see that, but that will never be a requirement. And you do have the option when you're writing Java classes, you can initialize them right in line as you create them as well. So you'll see a mix of this. Sometimes I'll initialize variables in a constructor, and you'll have this option too. Sometimes you'll initialize the variables in the constructor, or sometimes if they're always initialized to the same thing every single time, say you don't want people to choose their max HP, it's always going to be 10. You can just set that right here in line when you declare the variable. You can also initialize it in the class itself without even getting the constructor involved. Perfectly valid to do. And we'll do that quite a bit. We'll use both ways. Like I said, we'll use both ways throughout the semester. And you're welcome to use whatever makes sense for you in your homework assignments. And instance variables are private. Our last concept of the entire lecture, really. We're going to do two big, most of the rest of it's two big memory diagrams. Instance variables should, I say very common in Java in the slide, but should always be private in Java. This is something I will hold myself to throughout this semester. You're not going to see me with a non-private instance variable in Java unless I forget. I make mistakes sometimes. Sometimes I forget to type private. But I think I caught all those last semester. I believe I updated everything. Instance variables will always be private. You cannot access these instance variables from outside of the class, meaning nobody can access these variables, max HP, HP, and name. And this is the idea, is that we want to encapsulate the how. We're going to hide all the details of how we're actually storing the state of this object and not let anybody access those. And more importantly, not letting anybody change these values. So how does anybody interact with their objects? We created this class and we said, hey, use this class. You can use it to create player objects. Oh, but like most of the stuff, we're not going to let you touch. How do they actually use their objects? Getters and setters. Yay, everyone's favorite Java topic. Getters and setters. My goodness, we're going to have so much fun with these. Instead of just making these public and let people access the variables directly, we're going to use getters and setters. So we have public methods for each, what's up Explosion Galaxy? So for each instance variable that we have, we're going to have a getter method that, Java. So we have a getter method that's going to return the value. Oh, and I missed my this dot. I just said Java devs, why are you mixing things? I'm mixing things right here. And so I missed my this dot. This should have this dot, and this dot. It's technically optional, but I like to always have it. So the getters, get and then the name of the variable, will return the value currently stored in that variable. And then a setter, set, and then the name of the variable is going to take a value and then set the variable to that new value. And then this is how we allow people to interact with the state of their objects, is through the getters and setters. That's the way, the Java way to have people interact with your variables. So starting last semester, we switched the course to Java from Scala. Starting the upcoming semester of 250 will also be switching over to Java. So we're cascading the change from Scala to Java throughout our program. And we're going to be done with Scala moving forward. Scala was an experiment. There are pros and cons. We weighed all the pros and cons and said, you know what, let's stop with the Scala stuff. So other languages have different ways. Well, let me get to the why slide. Other languages have ways of getting around the problems of this, and you won't use getters and setters in every language. That's why I say it's the Java way. This is how we access our state of our objects in Java. And the reason is control. This is the primary reason to have private instance variables and then public getters and setters, is we can control things. So say we have this code on the previous slide. Our getters and setters just do the simple dumb thing of getting and setting. And then later on down the road, we decide, you know what? People shouldn't be able to just set their HP higher than their max HP. So if somebody tries setting it higher to their max HP, we're going to set it equal to their max HP instead of that value that's even higher than their max HP, because that doesn't make sense. We don't want to let people do that. So we just modify our setter, and we add some code to our setter to put that control in there. Sanitize, what we call sanitizing the inputs. Whatever we got from the user, we don't want to use that just as a raw value in most cases. We want to sanitize it. Is this greater than max HP? If it's greater than max HP, you don't get any higher than max HP. Same thing with our getters. Maybe we want to format our values. Maybe our getter is for an instance variable of type double, and we don't want people seeing the like 3.0000000 and then a 4 like way out there like we saw with the truncation errors. Maybe we want to round those values before returning them. Maybe we want to format our strings to be to have, be a little prettier than just the raw value that we're storing. To the point where people don't have to care how we're storing values. They can call the getter and then get whatever the value in whatever form we want them to show. We want them to see. Maybe we have a grid system, and internally we store everything in polar coordinates. But when we return things to the user, we want them to see XY coordinates. If we just gave them access to our instance variables in polar coordinates, people are going to get confused. Everything's going to be crazy. The whole world's going to light on fire. People will be like, what the hell is this polar coordinate stuff? So you have a getter that's going to convert your polar coordinates to Euclidean coordinates and then return the XY values instead of polar coordinates. Examples like that. Those are reasons you would want your getters and setters to be there. And if you don't use getters and setters right from the start, even like get max HP, set max HP, we don't have anything that we're doing here. We're just doing the plain old dumb stuff here. But we have the option of doing something different later. If we do want to change our mind later, we have that choice. We can add this code later, and since everybody else's code is calling set HP instead of doing HP equals, we can add this sanitation later on down the road whenever we want. If we have people accessing our variables directly, and down the road we say, oh yeah, you can't set HP higher than max HP. We can't enforce that. We lose control over our own class, objects of our own type, because we didn't use the getters and setters. So this is the reason why we use getters and setters, even if we're not doing anything fancy with them. We use our getters and setters to give us those options down the road to be able to just have more control over how people use our code and to not break things. If you have a huge project with 20 developers and the other 19 of them are all accessing your variables directly and you want to make a change because they're all breaking everything, that's going to be hard to make that change. You got to go to all your coworkers, hey, you're not supposed to use it like this. You got to use it like that. I've told you this 100 times before. You got to do it this way. You can't. You're breaking my stuff. You're causing bugs. Just write your getters and setters from the get-go, and then you can add that code and then not have to ask everyone, please use my code the right way. Just put it in the getter or setter. Problem over. Like I said, other languages have fancy ways of getting around this. So when I used to teach in Scala, speaking of actually, when I used to teach in Scala, I didn't use getters and setters at all. I didn't use access modifiers at all. Just because the language is set up different, that these same problems don't occur. Python as well, JavaScript, C#. There are a lot of languages that got around this without using getters and setters. C++, to my knowledge, you still need the getters and setters for the same reason. Are all setters void? Yes. So the setter's void, its job is to have the side effect of changing the state of the object, and we don't need to return anything. And the getters will always return the type of whatever's being gotten. Gotted? Whatever's getting got. And then I regret this slide, but I built the whole memory diagram off of this, so I'm not going to change it right now. Maybe for next semester. That you should call your getters and setters in your constructor. This isn't necessarily true. It's not true for the same reasons of why we use getters and setters. Because if you want to add some sanitation to your setter, you could also at the same time update your code in the constructor to call your setter. So you shouldn't always call your setters in the constructor. It's a good idea in like this case where set HP has some sanitation. It's a good idea to call your setter. And it's a good idea to call your setter in program task 1 when you have the rating class where the ratings need to be sanitized to be an int from 1 to 5. There it makes sense to call your setter in the constructor, or else you're going to take that code and cut and paste it from your setter to your constructor. Why not just call your setter that has the code? But later on in the semester, I'll start doing this dot max HP equals max HP, this dot name equals name, and then this dot set HP to max HP. Even then, just because of the logic here, I wouldn't be mad at this dot HP equals max HP, because you know this logic isn't going to come into play anyway. So depending on your situation, you might want to or you might not want to. Like for your homework and your rating class, calling set rating is going to just cut down the amount of code you have to write. But set reviewer ID, calling set reviewer ID would increase the code you have to write. So you can make your choice on whether or not you want to call your setters in your constructor or not. But if you do have checks like that, sanitation checks especially, calling your setter just cuts down your code you have to write. And the code you have to maintain, and the code you have to test. We like to just test things once. It's a lot of work testing things. We like to test things once and then reuse that code. I don't want to write even more code and then test my constructor in addition to my setter. Just makes things easier in some cases. And now that we created a class, where the real magic comes in is a class defines a type. So Java is strongly typed. Every variable needs a type. Every method, aside from the constructor, needs a return type. Every parameter needs a type. We have types all over the place, and the types have to be specified, and we've used int, string, double, boolean, array list, hash map. We have a handful of types that we use, but we're somewhat limited to the types that are built into Java until we start writing classes. So classes define new types. When we created this player class, we created the player type. So now anywhere in our code where we could use any of our other types, we can use the type player. This is anytime we have a variable, we can have variables of type player that store references to player objects on the heap. We can have parameters of type player. We can have methods that return references to players. And we can have that's the one I missed. And we can use player as a type parameter. We can create an array list of players. Now that we have the player type, we can use it anywhere we use any of our other types. Aside from our primitives. Primitives are a little special case. But we can use our new type anywhere that we can use any of the capital letter types. So including type parameters and data structures where we couldn't use int. The primitives are a little more restrictive in that sense. We created a full type that we can use anywhere in our code. So if there's a type we want to use that doesn't exist, we just make it exist. We write a class for it, and then it exists. We're on the next slide. This slide deck is, I think these next two are a little less than the 50 minutes for a lecture. But that first one's definitely more. That one might have to, that one and a lot of the ones that we went through last week, I think those have to get trimmed down a little bit. No way I can fit those in 3 50-minute lectures. memory diagram. These two lectures are, part 1, part 2 of the same thing. So let's take a look at that code that we saw last time. I almost said last time, but that we just saw. My brain's programmed for these to be 2 separate lectures. Where we have the player class, I trimmed down a little bit. I don't have all the getters and setters. I'll do this a lot throughout the semester where I'll cut down on some code just so I can get it to fit on a slide. Because I just can't fit all that stuff on a slide without making the font super small. Which online that might not be as big of a deal. It's designed to be on a big projector. Oh, speaking of, let's move myself here. Where do I want to be? Just fly around. I will need this space. Can I just float right here? Would that be weird? Maybe I can go right here. And then shrink me down a little bit. I'm going to hang out right here. Yeah, that should be fine. So, all right. So I cut down some of the code. That's just for it to fit on the slide. They're designed to be on a projector where some students are, 100, 200 feet away. But I'm going to obviously keep that. I'm not going to change all my slides. But and I think it's still helpful. It would still get pretty small if I put the whole code here. But whenever I do that, the whole code will be in the repo still if you want to see the more expanded code, including dealing damage between players, which I cut for my slides for my memory diagrams. But here's the code that we saw without all of the getters and setters. Oh, by the way, just another side note on getters and setters. If there's a variable that you don't want to allow people to set, you make it private like any other variable, and then you just don't write a setter method. So if it's something that should only be, you should only be able to get the value, but you shouldn't be able to set it, just don't write a setter. So that's another advantage that gives us more control, making our variables private, and then defining how people can access those variables. And then we're going to add a main method. So in this code, we're going to create a new player. So we're calling our constructor. That's going to create an object on the heap and give us a reference to that object on the stack. We're going to see how this behaves when we hit these next 2 lines. We're going to talk about the differences between these 2 lines. We're going to call a method on one of our objects, and we're just going to print something out, calling another method, calling a setter and a getter. So just doing some basic object stuff. It's basic, but you're also seeing it for the first time, so we don't want to throw too much out there. Constructor calls, setter, getter. Let's see how it all works in memory. So let's do this. So we'll set up our stack heap, our in out, same way that we've done it before, and then very quickly it becomes something very different. So this is the first time that we're seeing an object go on the heap that's not an array list or hash map. Array list and hash map, we do treat a little bit differently with the T-charts, with indices to values and keys to values. Those are kind of special cases. So this is our first true object that we're tracing. So let's talk about how we treat objects a little differently. It's kind of still the T-chart. It's the same idea here, but we do box it off. So we box it off. So this is going to be our object on the heap, and it's the same idea still, where we have names of our instance variables and values of those instance variables. Objects are going to have references. Instead of putting the reference, and we're actually talking about changing this and representing array list and hash map the same way we do every other object. I'm not sure why we treat them differently. But we will put the reference instead of on top of the T-chart. We're going to put it below the object and then choose our random number for our reference, just like we did before. I was feeling 999 when I made this slide. And then above the object, we're going to put the type of that object. So we don't care about the types of our variables on the stack. We're not going to care about the types of our instance variables. But the types of our objects, this is much more important to track in our memory diagrams, which for a reason that'll make a lot more sense when we get to, it'll make sense now, I think, in my opinion, But it'll make even more sense when we get to polymorphism later in the semester. We need to know the types of our objects on the heap so we can know how they're supposed to behave. So we have an object of type player at memory address OX999, and we have some space for its instance variables, which we're going to do right now. So when we create an object on the heap, we're going to look at all of the instance variables for that object and put all of the names of the instance variables down. Max HP, HP, and name. Every variable that's outside of any of the methods, which, by the way, you could, we kind of saw it when I was going through the Java code. You could have another instance variable defined like way down here or even after the main method. By convention, you'll usually have, you should, I don't know why that, I forget what class I was even in, the system. I wasn't paying enough attention. There might have been a good reason for that based on standard ordering. But you put all your instance variables right at the top of your class, very first thing. Then any constructors, then your methods, and then the main method, if you have one, will go way at the bottom of the class. So that's our standard ordering. You'll always see my main methods as the last method of the class. It can go anywhere. Like Java will still run your code. You can mix these up in any way you want it to be. But that's our convention. If I go to somebody else's code and I want to check out the main method, I open the file before I even read anything. I just scroll right to the bottom because that's where I should find the main method. So a way of communicating between developers, making things consistent and easy for other people to understand your code, following those conventions is important. Or else when you do get on the job, your teammates are going to get mad at you if you don't follow conventions like that, as they should. We tax our brains enough. We don't need our teammates taxing our brains even more by having to search for their main methods. Anyway, so every time we create a new player object, that object is going to get its own copy of all of the instance variables. So this is very important. The instance variables are not shared between objects. Each object gets its own copies of the instance variables. For example, if you created two array lists, you don't expect those two array lists to store all of the same values. You expect two different array lists with different sets of values. So that's the advantage of instance variables, is that each object has their own copies of those variables. When we call the constructor, that's a method call. Constructors are methods. We defined it just like a method. It's a special type of method, but we defined it just like a method. We called it just like a method. We don't have our type parameter getting in the way here. It's more clear to see that this is just a method call. We're calling a method named player that takes a string and an int. It's exactly what we're doing, but since it's a constructor call, we have to use the keyword new. That's the only difference, is we have this keyword new here. Otherwise, this is a method call. That means it creates a stack frame. That means we need the name of the method call here. It means we need the return arrow pointing to where the return value is going to go. So we have a variable p1 that's going to go on the stack. We're going to call this method the constructor, which will resolve to a reference to the object that's being created. And the return arrow is going to go into p1. P1 is going to get that reference once the object is done being constructed. Did I not have my... Maybe it's the next slide. Oh, I do have my note. I was going to say, what else is my note? So when I'm drawing these slides, I have two notational notes today. Here's the first one. I recommend, in the first memory diagrams I did with the array list and hash map that had references, I always draw these arrows, always, in the two memory diagrams. I drew these arrows showing that this reference is a reference to this object. The arrow makes it 100% clear that reference is referring to this object. But when I'm doing my memory diagrams in my slides, I'm not going to draw those arrows anymore. I'm going to stop doing those arrows. I do recommend that you draw them on your quizzes, but it's not required to draw them on your quizzes. I'm going to stop drawing them because I can do things like color coding my slides, and I double check things, and I'm not trying to rush doing my whole memory diagram in half an hour because there's a time limit. I got another quiz to do. Like I have time to to make sure these things are tight. Plus, I used all these slides last semester, and I did have some mistakes, and I was able to correct them and update my slides and everything. So I'm not going to do my arrows anymore. I'm going to color code them so it's still clear, I think, that this reference refers to this object. But in your memory diagrams for your quizzes, I do recommend the arrows. The reason I recommend them is if you're not drawing your arrows, you're one typo away from losing credit on that quiz. Well, not necessarily losing credit, but getting closer to losing credit and having a mistake on there. If you write the wrong number in one place, we don't know anymore. If you write 998 and you have another object here that's 998, I'm thinking you're referring to that one. If you have a reference that doesn't refer to any object on your heap, I don't know what you're talking about. We can't just assume that you wrote the wrong number. We would have to assume that you don't understand the material, and that is going to lean us towards failing you on the quiz. So if you draw the arrow and you have the wrong number, you write 253 right here, but you have an arrow pointing to this. Now we can say, oh yeah, they just wrote the wrong number. No big deal. The arrow's pointing to the right thing. We can give them credit for that. So I do recommend the arrows because it gives you a better chance of earning credit on the quizzes, even when you make mistakes. It's kind of a form of partial credit. Of course, it's pass fail. There's no actual partial credit, but it's kind of like partial credit. It's not clearly wrong. You probably know what you're doing, and we can give you credit for that. So I recommend them, but I'm not going to do them in my memory diagrams in lecture, mostly because when there's so many arrows, it's just so hard to read what's going on. We're going to start having memory diagrams where arrows are going all over the friggin' place. It's really cluttered when I draw the arrows. Okay, onward. When the constructor is called, this is going to be a reference to the object that's being created. So this will go on the stack, inside the stack frame, for every, and this will be true for every single non-static method call. For static method calls, we don't write this in our memory diagrams. It's technically still there. You have a reference to the class itself, but it's something we're not going to worry about. It's something we're not going to use either. So, but this we will use. You can see this all throughout this code. This is going to be in every single stack frame for a non-static method, including constructors. The first value in every stack frame, every non-static stack frame, is going to be this, and the reference stored in this is going to be a reference to the calling object. That's how I always say a reference to the calling object. For a constructor, it's the reference to the object that's being created, and for any other method call, it's the object through which that method was called, which I call the calling object. So for the constructor, this is a reference to the object being constructed. So when I hit this constructor call and I'm doing my memory diagram, I'm going to put P1 on the stack, get my stack frame for the constructor call, return arrow goes to P1. I'm going to draw my object on the heap with the type of that object, the instance variable names for that object, and then I'm going to make up a number for the reference, and I'm going to put that reference below the object and in the stack frame. And then I'm going to look at my parameter list just like any other method call. Most of that's new to constructors, but also getting my arguments set to my parameters, arguments, and getting all those in that stack frame as well. And then if I know I have any local variables in the stack frame, I'll leave myself some extra room down here. So we have our constructor call on the stack, and now we're ready to execute this call. So control is inside this method call, which is inside this stack frame, which is outside of the main stack frame where P1 is going to live. And then we execute line by line. So we're going to call this dot set max HP of max HP our first kind of second method call, if you count the constructor. So when we call this method, here's the big thing, keeping track of this. For the constructor call, we just made up this and made sure it matched whatever object we're currently creating. Whenever you call a method, this is a reference to the calling object. And the dot operator means follow the reference. So this being called from this stack frame, this is OX999. Dot, we're going to hit the dot operator, which means follow the reference. So we're at this object right now after the dot operator, and then we call set max HP. So we call set max HP from this object. It's of type player, so we look in the player class for a non-static method named setMaxHP, and that's the method we're going to call. We put that method call on the stack, and here's the important part. Since we were at this object when we called the method, this is the calling object. So in our new stack frame, this is going to be a reference to that calling object, which is OX999. Now, of course, there's only one object on the heap right now, so you could not understand any of that and just write 999 and you'd get it right. But that's why it's 999, because that's the object we were at when we called the method. That's where we were at in the heap. And then this dot max HP equals max HP. So we had an argument and a parameter here, so get that on the stack frame as well. And this dot max HP equals max HP. This dot max HP. So this, inside this stack frame, we find this, which is the value OX999. Dot means follow the reference. So we're sitting at this object here. And then we're looking for a variable named max HP. So this dot max HP is going to find max HP right here, which is important to keep track of because there's also max HP right here. The difference between this dot max HP means this dot go to the heap, or HP, if we just do HP, we're in the stack frame at that point in time. So we're going to look inside the stack frame for a variable named max HP. This dot max HP means go over to this object on the heap and look for a variable named max HP. So getting the variables right, knowing where you are you in the stack frame? Are you on the heap? Which object on the heap are you at? That's going to be important to figure out what variable is being referred to. So this dot max HP equals max HP. Oh, I could have clicked through that one. So this dot max HP equals, on the right hand side of the equal sign is just HP. So it's just max HP. So that's inside this stack frame still. We always start at the stack frame, and then we only head over to the heap if we hit a dot operator. So this expression resolves to 10. This variable is the variable, this dot max HP, this max HP right here. So this max HP is going to be 10. That's the crux of it. There's a lot of juicy content there. A lot of concepts there. If you can follow that whole thing, you're doing great. If not, don't worry. We got a lot more memory diagram to go. We're going to hit that point hard and over and over. All right, so another notational note to cool down from the new concepts. I'm just going to gray out my stack frames instead of crossing them out. In your memory diagrams, you'll cross them out still. In my slides, to make things more legible, like sometimes your memory diagrams are hard to read because everything's crossed out. There's lines going through everything. It's hard to read everything that you wrote throughout the whole thing. For my slides, I want them to be legible so you can still see what's going on. Like even after a stack frame is removed from the stack, this is no longer in memory. It's crossed out. But I want you to still be able to read the values there. So I'll gray them out instead of crossing them out. Just, again, keep things clean, readable, so you can see what's going on with this memory diagram. But for your quizzes, still just cross them out. For your quizzes, I recommend having your arrows. But you can see by the time we get to the end of this, there would be arrows all over the place. And cross marks out all over the place. For grading your quizzes, we'll figure it out. We'll figure out what you meant. We'll sit there and spend the time and squint at it and things like that. Or Gerline will, rather. Sorry, Gerline. But for the slides, I want them nice and clean and legible. So you can learn. All right, so now we do the same thing with set HP. This dot, so we're inside the player constructor call. So we're in this stack frame. Oh, by the way, once this stack frame is removed from the stack, this stack frame becomes the active stack frame again. So we're back in this stack frame. When we're in that stack frame, we're calling this dot set HP of max HP. So we're inside this stack frame, and we say this dot set HP of max HP. So max HP, we're going back again. Every expression we start back in the stack frame. Max HP from the stack frame, we're not doing this dot. We're just taking max HP right here. They happen to be the same values, but if they weren't, we would grab this value right here. This 10, that's what we're passing into our stack frame for HP. And then when we get into this stack frame, we're doing this dot, well, checking our conditional. This dot HP, I assume you all know conditionals. I don't have to go through that step at least. I guess the one new thing is this dot max HP. This dot max HP 10. 10 less than equal 10 is true. So we're going to hit this line of code. This dot HP equals, start over again at the stack frame, HP. So HP, this dot HP equals 10. We get 10 right here. That stack frame ends. Then repeat the process for name. Again, name strings, we're treating them as though they were on the stack, as though they weren't passed by reference, even though they are. A little nuanced thing. But this dot set name of name. So this dot set name. So this in the new stack frame is 999 because the method was called through this object. And then give it the name. Give it name from this stack frame. So pass this as the argument. And then this dot name equals, start over again at the stack frame, equals name. And then get our instance variable set the way we want. Set name returns, gives control back to this stack frame. This stack frame hits its closing brace. So this stack frame is removed from memory. Again, you would cross all four of these out. And then we're back, control goes back to the main stack frame, and P1 gets the return value of the constructor. Constructors return a reference to the object that was created. So that reference, OX999, is the only thing that's stored in P1, not the entire player object, just a reference to that object. Okay, and then we get to the next line, player P2 equals new player. We're going to create Kane to go along with Dark Cecil. And I'll quiz you on this one. What happens with P2? We're trying to initialize P2. What's going to happen? I'll give you a second to stare at that, kind of digest everything that just happened. And then I'll click to the next slide, I guess. But I'll let everything chill for a second. If there are any questions, I can take them. But I want to see who understands this. I guess I won't really see, but I want you to test yourself, see if you understand this. What's going to happen in this next line? I guess I'll just sit here. All right, I'm too impatient for that. I should wait a little longer, but I guess you could pause it if you really want to test yourself. Oh, or I'll go on a mini lecture to give it a little more time. Identical thing with a different address. I like that answer. So I do recommend so strongly actually trying to do these memory diagrams. I've seen far too many students. We're going to create a new object on the heap since it uses new. All right. Yeah, we're getting good answers in here. I do recommend actually doing memory diagrams. It sounds weird to even say this. I can't believe I had to say it. But so many students I see going into the very first quiz, and the very first time they've ever done a memory diagram in their lives is on the first quiz. And of course they fail the quiz. And the failure rate for the class on the first quiz is always around 50%. Like half the class can't get that first quiz down when it's just like the basics of memory diagrams. They just don't even understand the basics. They're putting things in the wrong spots and everything. Do at least one memory diagram completely on your own. Take up some code. Maybe even look a lecture ahead and take one of my slides where I'm going to do a memory diagram. Don't look at the memory diagram, just look at the code. Draw your own memory diagram and then see if what you got matches what the slides will show. And right here, here's your first opportunity to do that. Actually do the memory diagrams. Make sure you have, don't forget the little things and can do it all right. But I am seeing the right answer in chat. So the same exact thing will happen, except we'll have a different reference right here. The quizzes will be, I'll give you a chunk of code. Like this would be a reasonable quiz, by the way. I'll give you a chunk of code. This is reasonably sized. This I would expect you to be able to do in 30 minutes on the quiz. You have an hour for the quiz, but there's effectively two quizzes. This would be one of them. This could be one of them. It obviously won't be this code, but similar concepts. I'll test the same concepts and everything for the Classes 1 quiz. The Classes 1 quiz is all about today's lecture, by the way. I'll give you this code, and then you have to do the memory diagram. And then you'll somehow, I'll leave this pretty flexible. I'll leave it up to you all. I envision somehow turn that into an electronic form and submit it on Autolab. What I assume most of you will do is take a picture with your phone of the memory diagram that you drew with pen and paper, and then upload that to Autolab. But it'll be a memory diagram. You'll get the code, you draw the memory diagram, and you submit your memory diagram. No multiple choice, no short answer. Just a memory diagram, and that's the whole quiz. So for the quiz next week, you'll get a memory diagram that looks similar to this about classes. You'll get code. Sorry, you won't get a memory diagram. You'll get code about classes, and you'll get a piece of code about linked lists, and you'll draw two memory diagrams and submit each memory diagram to Autolab separately, because there are two quizzes that are each graded independently. And if that memory diagram's good enough, you pass. If it's not, you don't. And by that, we look for any major misunderstandings of the material. If there's any major misunderstanding, which again is a little vague, which is still a little vague, but if there's a major misunderstanding, like you don't even understand how objects go on the heap, you're going to have to take that again. But if there are no major misunderstandings, we'll give you a pass on it. All right, so the same exact thing happens when we hit this next line. Player P2 equals new player Kane. We got P2, we got our constructor call. We call the three setter methods. We create a new object on the heap. We saw the keyword new, so we're creating a new object and returning a reference to that object on the heap. And when I made this slide, I was feeling 820, but this is any number that you want it to be, as long as it's consistent. If I choose a different number here, all these numbers have to be different values. What the actual value is doesn't matter, but that you're consistent does. Because I want to make sure you understand that P2 has a reference to this object that you just created. That reference is passed through all the other method calls. That's what I want to know. So my next quiz for you, what happens on the next line? We have a line that looks a little bit different. Player P3 equals P1. What happens here? And I got a few questions to answer. Well, we have that, so you will get some time to think about that one. Can I draw it on an iPad and submit as PDF or only on paper? I don't care how you generate the memory diagrams as long as it makes it into a PDF. Does it have to be a PDF? We'll see how the first one goes. I'll say it has to be electronically submitted to Autolab. If it gets to be a pain when grading, I probably will say it has to be a PDF. We'll go through the first one, and I'll talk to Gerline about whether it should have to be a PDF or not. But I'll say PDF recommended it for now. If you submit a PDF, you have a PDF viewer in Autolab, and you can see your submission and verify that it's submitted correctly. So there is an incentive to use PDFs. How many questions are there in each quiz? If it's 2 in 1 hour, 1. So each quiz is one single memory diagram. Like this would be an appropriate size for the for quiz 1. So next week you're taking quiz 1 and quiz 2. This would be an appropriate size for quiz 1, and that's the entirety of quiz 1, and then a similar amount of code for quiz 2, and that'll be the entirety of quiz 2. So each quiz is one single memory diagram, and you have 1 hour to complete them both. So I'll design them for my expectation to be that you complete that memory diagram in half an hour. And that's what I'll keep in mind when I'm making the quizzes. Like, is it reasonable for a student to do this in half an hour? If my answer is no, I got to cut some things down. If the answer is yes, I'm shipping it. But yeah, I answered that right. Did I answer that thoroughly enough? However, you can get it electronically into Autolab. If you generate it electronically, I'm fine with that. If you generate it on paper and then take a picture of it, I'm fine with that. If you generate it on paper and scan it with a scanner, I'm going to say I don't care, and then if it's a logistical nightmare for quiz 3 and 4, when that comes around, I might give more detailed instructions. But if it's not a nightmare grading, I'm just going to leave it up to y'all how you want to submit. Do getter functions go on stack and or heap at all? Yes. We'll see that right here. This getter will go on the heap. This getter will go on the stack. There will be a stack frame for get name. Every single method call will get, I'll have one caveat to that. I did talk about it earlier, but now that we're getting more used to this, I'll remind you all. That print line won't go on the stack in our memory diagram, but it does go on the stack in reality. But yeah, all method calls, if you can see the code for the method and it's being called, you're putting a frame on the stack 100% of the time. Yes, a new mischief, you got it. So the grayed out, I'm just graying them out because I can do that on the slides. You can't quite do that on your memory diagrams. I mean, if you have a pencil and you want to like shade it in, I'd be okay with that as long as I can read what's underneath it. But what I expect is you just cross them out. Just put an X through it, and that denotes that it's no longer on the stack. Thanks, Mossballs. Or Mossball. Mossball's got it. Alright, so on this line, I saw the right answer in chat. P3 just gets $9.99. Nothing fancy happens here. The shortcut for this, we talked about this a little bit when we saw array lists and hash map. P3 equals P1. When you have a variable, getting the value of another variable, when you're doing your memory diagram, you find that variable, you look at whatever's written right next to it. I don't care what's written next to it. Just whatever's written right next to it. In this case, it's OX999. That's what you write next to your new variable. Period. Don't overthink this. I don't know how many times I've seen player P3 equals P1 because I will always put this on the first quiz. There will always be this assigned by reference 100% of the time, unless I completely lose my mind and forget. But how many students will say P3 equals P1, and I'll see a third object on the heap over here? Makes it really easy to grade because at a glance, if I see 3 objects on the heap and this was your quiz, you failed that quiz. You 100% failed that quiz because you don't understand references. P3 equals P1. P3 just gets the reference because that's all that's stored in P1 is a reference. It only gets that reference. There is no third object that's being created. A shortcut for this, if you want to double check your work, look through the code and see how many times the keyword new was reached. Now, new could be called inside a loop, so I say is reached, not how many times it appears in the code. but how many times you executed a line with the keyword new, that's how many objects should be in the heap when you're done with the memory diagram. If those numbers don't match, you did something wrong somewhere along the way. So new was hit twice when we ran this code. Even by the time we get to the end of the main method, I only expect to see 2 objects on the heap. 3 objects on the heap, you're wrong, you're taking the quiz again. You lost that chance at an AO. Make sure you're understanding this assigned by reference. P3 equals P1. P3 just gets the value of P1. All right, and then moving on. P1.setName. We're going to upgrade Cecil to a Paladin. P1.setName. We're looking for P1. P1 is the reference OX999. And we're doing P1.setName. So we're at this object when we call setName, which means in the setName stack frame, this is going to be a reference 999 because that's the object we were at when we called the method, was the reference OX999. So this is OX999. Oh, my shading got different. Or is that just my monitor? I think that's my shading. I got a lighter yellow here. They're still the same. They're the same references. And then give it Paladin as the value for the parameter. And then this dot name equals name. This dot name, we're talking about this variable here, equals name. We reset and go back to the stack frame each time we're evaluating an expression. So name is going to be back at the stack frame, which is Paladin. We cross out the old value, write in the new value. Now the importance of this is, and this is really why we need to understand references at all, is we have a situation where P1 and P3 both refer to the same object on the heap. If you don't understand references, and you never heard of references before, and you're reading this code, you would be tempted to think P1, that player, they changed their name to Paladin, but P3's name didn't change to Paladin, so P3 should still be Dark Cecil. Very common mistake. That's the big thing I'm trying to show you with these references. But that's like the big thing people would think when they first start seeing this stuff. And hopefully something that none of you will think when you're doing the quiz. You're going to do this the right way because you'll understand references. So since P1 and P3 are not different players, they both store references to the same single player on the heap, the same player. Whenever we make that change, we made that change to that player through P1.setName. SetName looks exactly the same as it would if we said P3.setName. Because the only difference is, whatever the calling object is here, that's what this is when we get into the method. So this.name, when we change that name, it was based on the reference stored in this. And that would have been the same if we did P1 dot and went to this object, or P3 dot and got to this object. Once we hit the dot operator, it doesn't matter which variable we came from. All that matters is what reference was stored in that variable, because that's what determines which object we make it to in the heap. We made it to this object through P1, but it doesn't matter. P3 still sees that change. P3 refers to the same object and also sees that Dark Cecil changed to Paladin. Because we gave this method a reference, well, through this, but we gave the method a reference to an object, the method went over to the heap, messed with that object. Even though this method returned void, it had the side effect of changing the state of that object on the heap. And even when the stack frame's gone and it returned void, it seems like it didn't do anything. It did have an effect on the program because it changed an instance variable of an object on the heap, and objects on the heap don't go away when stack frames end. They sit there and they live on beyond the stack frame. So we changed the state of heap memory. Stack frame ended, we got a new stack frame here. P3.getName. But P3 dot get name, we're calling it through this same object. This is going to be a reference to that object, and we're going to return this dot name. This dot name is Paladin. So even though we didn't say P3 dot set name, its name is effectively changed because there's no difference between P1 and P3. They refer to the same object on the heap. They're just two different variables that happen to store references to the same object. So they both see any changes that are made using the other variable because they're referring to the same object. This is very important in things like calling a method that takes a reference to an object, because that method, just being aware that that method can make changes to the heap is a big deal. Like being aware of that when I get this object, that stack frame ends and it returns void and I still have a reference to that object might have changed. That method might have changed something. If I gave it a reference to an array list, it might have added things or removed things from that array list. And you don't really know if it did or didn't. So it's something you always have to be aware of. When you're calling a method and handing it one of your precious references, it might be changing your object. And when you're writing methods that take references, being careful and aware of that. Like, should I change this object on the heap? Most of the time the answer is no, unless that's the method's purpose. Like a setter, its purpose is to go to the heap and make a change. Most of the time you don't want to. And did I miss my note? I had one more note here. I'll just say it briefly because I mentioned this one already. But anytime you have, for your quizzes and memory diagrams specifically, whenever you have access to code for a method that's being called, you have to put that stack frame, you have to do the stack frame, do all this stuff, memory diagram stuff with it. If you don't have access to the code, you don't have to do the stuff. You don't have to trace it in your memory diagram. So p3.getName, the getName method, we have access to the code. So this we're going to draw on the stack. But printline, we don't have access to the code right here. So I don't know what I would expect you to do. Like you could draw the stack frame for printline. There is a stack frame that's created for every single method call. But since I didn't give you the code for printline, I don't know. Do I expect you to just put an empty stack frame? Like what would you even put for the reference? I would have to have you create an object for out for this output stream. Put that on the heap with a reference. Like it would get out of hand quick. So if it's code that you can't see when you're taking your quiz, you don't have to trace it. Even though there technically is a stack frame created for printline, you don't have to trace it. But you do have the method getName, so that you do have to trace. But anything internal to Java is the general rule of thumb. If it's internal to Java, I don't care I don't want to see you trace it. Because it's like when I asked you to trace this for the memory diagram, really what I want you to show me is, do you understand the heap and references and constructor calls, I guess. And this, all the reference stuff really is what I'm quizzing you on. I'm not quizzing you on, oh, printline, that technically creates a stack frame. Gotcha. Like, I'm not doing that kind of stuff. So we just don't trace it. It's not relevant to the learning objective that I'm testing at that moment. Then the program ends. Oh shit, I do have some extra slides here. It's just a couple, right? Yeah. I'm going to go through these quick because we're a little bit off track. We're a little bit behind for getting through the next one. There's one slide with a whole bunch of meat on it in the next memory diagram I want to make sure I get to. So when you're doing your memory diagrams, something to remember, only your primitive types and strings and your auto box types, these are, a little different, but only these values are stored directly in your variables. If your variable is of type double, you put the value right next to that variable. If it's an int, like our HP and max HP, we just put the value of the int right next to that variable. Same with strings, we put the value right next to the variable. Everything else, anything that's not one of these primitive types, and the asterisk string technically falls into the everything else, but as I mentioned before, we're going to simplify things. The auto boxed values are, there's objects, they're on the heap. They are implemented a little different, but we're going to pretend that they are just as values, stored as values in our variables. Everything else is going to be a reference and stored on the heap. Everything else. If it's not one of your primitive types or string, it's on the heap. It's on the heap, and you only get a reference to that object stored in your variables. Everything else is references. Oh, I should move myself. Oh. And for the next memory diagram, I'll find a new home for me, for my face. So everything else is on the heap and references. Now, this includes every single object created from any class that you ever write, ever. Every single class that you write, whenever you say new, my class name, that's an object on the heap, and your variable only stores a reference to that object. Everything. Everything goes on the heap. That's not our things. Hopefully I said that enough times just there. And my double asterisk here, we do have another disclaimer. This one's less relevant. I think there's fewer people who get mad if I didn't. Efficiency optimization things, where even these auto-boxed types often go on the stack directly as values in their variables. And certain objects, things aren't always exactly where we would expect them to be. But when we're doing our memory diagrams, we're concerned with how our code behaves, because that's what we really care about. If the compiler does some fancy-ass thing that speeds things up by a nanosecond, that's cool. I like that the compiler is doing that, but it doesn't affect the way that we're going to code, at least in 116. It's not going to change the way that we code. And it's certainly not going to change the way that we trace our memory diagrams, because it's not going to change any of that behavior. It's not going to change whether something's passed by reference or not, like whether that reference can be used to make a change on the heap. It's not going to change any of that. So we're not super concerned about the details. And then the toString method, we'll talk about this a little bit later when we talk about inheritance. But in a week and a half, next Thursday. But if we print out an object of a type that we created this player class, and we print it to the screen, we're going to get something like this. We're going to get the fully qualified name of the object type, the @ symbol, and then some random hex value. It looks random to us. It's not quite the memory address where the object's stored, but it's related to that. Just some random garbage to us, which is almost always not what we want. But if we write a method named toString that returns a string, and it's public and it takes no parameters, then that's what's going to be called when we call println. Println's going to call our toString method, and then we can print out our values in more meaningful ways. So this can be handy, especially when debugging. If you're debugging your objects that you create, sometimes it helps to write a toString method to give you more information that you wouldn't necessarily have. Ooh. And now that we defined a type, we defined the player type, we can use it wherever we could anything else. I mentioned this earlier, but I didn't show an example. So here's one. We can write an attack method that takes another player, and that's going to give us other player having a reference to another object on the heap. Then we can go to that object and call its methods, and then deal damage in this case. Okay, it was only 28 slides, but some of them slides are intense. There's a lot to talk about on some of them. Let's go right to 21 of more intense slides. But some of these we can breeze through now that we know constructor calls, method calls, this, references. We can get to the juicy bits, which there's two big things that I want to show with this example. Let you stare at the code for a second, kind of digest everything that's happened. But as I explain a little bit. But we want to look at this example where I'm going to highlight composition and garbage collection. Composition is just a fancy word for an instance variable that's also a reference to an object on the heap. I don't know why they use such a fancy word for it, but they do. That's something I was taught. Something that I didn't used to use the vocab for this, composition, for quite a while, and I don't care if you know if that's called composition or not, but I forget why, but I decided to bring in the vocab on a slide. And garbage collection. Something that I'm not going to stress too much again throughout the semester. It'll come up from time to time in lecture. I'll mention it. But I'm not going to be harp on it too much in terms of like memory diagrams. I probably won't ever have a quiz. Actually, I'll commit to this. I won't have a quiz where you would fail if you don't understand garbage collection. It's just not. It's not a learning objective. If you look through the learning objectives in the syllabus, garbage collection just doesn't really fit in any of them. Objects and classes, like we're covering right now, it kind of does, but I really want you to understand references is the real big thing that I need you to understand. References and objects on the heap. So we have this code. We're going to have something kind of similar to the code that we saw last time, but a little bit different. We have a character class and a party class. So we're going to have a party of characters, and we're going to track each character's experience points and the number of battles they won, and also the number of battles they won as a party. We're going to create a new character, replace that character with a new character, create another new character, have a character win a battle, call the win battle method, create a party, add our characters to the party, and then have the party win a battle. So let's see what happens throughout all this. And I'm thinking of a JRPG in this case. We have a party of two characters, our hero and our fighter. The hero won a battle solo before recruiting the fighter into their party, and then as a party, they fight and win a battle that's worth 20 experience. So composition, I already mentioned it, but it's this idea that instance variables can be references to other objects. I don't know why it has a fancy name, but it does, so there it is. But this is already intuitive because we defined a new type. When we define a new type with a class, we can use that type wherever we could use any other type, and that includes instance variables. It's not fancy and new about this, but it does get a fancy name. And garbage collection. So when we have an object on the heap and we don't have any references on the stack to that object, whether directly or indirectly. Oh, I don't have an indirect reference here, do I? I used to. We changed this example, and now we lost the indirect reference. But if there's no way for us to access that object anymore, if there's no way for us to access a reference to that object, we have no way of getting a reference to that object again, it will be garbage collected, or it'll be a candidate for garbage collection, I usually say. We have no control over garbage collection. It's all internal to Java. It kind of just does its own thing in its own way. But what will happen is when Java runs its garbage collection, it's going to remove that object from the heap. Since we have no way of accessing it, to us, it might as well be destroyed. And Java will say, yeah, I'm going to go in and destroy that. I'm going to free up that memory and allow that memory to be used for other things. When you ask me for memory again, I might reuse that memory and give you the same spot in memory because you don't need to store that other object anymore. Because if you can't reach it, what's the point? This is a very nice feature. Some languages don't have this. Most modern languages have it, except C. Most relevantly, when you take CSE116, it'll be taught in C. I don't know where the best place for me is going to be yet. I'll move myself again when we get to the memory diagram. In C, in CSE120, you'll code in C, which does not have garbage collection. And a major learning outcome of that course is maintaining your memory, managing your own memory. So you'll get deep into this without garbage collection next semester, if you take 220, if that's your academic plan. Some students like to split up 250 and 220, take one or the other, and then the other one later. But when you do take 220, this will be a big thing. Let's do a memory diagram. So let's go through this whole thing. All right, now I can move myself to someplace that makes sense. And right here looks perfect. I'm going to hang out right here in the code. So, starts off innocent enough. We're going to create a new character that calls the constructor. I've been calling this the default constructor. If you don't have any constructor in your class, this is the constructor you get, but I'll be explicit about things at this point in the semester. Eventually, we'll actually use default constructors. But this is what we would get if we had no constructor. It has no arguments, does nothing. So we're going to create a new character. We have 2 instance variables that come along with characters, and they're initialized outside of the constructor. We're going to initialize battles1 and XP to 0, which just makes sense. It wouldn't make sense to initialize those in the constructor, because everyone should start with 0, 0, 0 for a new character. I'm going to make up a number. The constructor has a reference to the object being created in this, and then returns that reference to hero. And then in the next line, we're saying hero equals new character. So we're taking the same variable, and we're calling a constructor again. We're returning into that variable, create a new character with new battles1 and XP variables, a new reference. New creates a whole new object. It's going to have its own reference, its own location in memory. And then we overwrite that old reference to the new reference because we assigned it to the same variable. This isn't something you would ever actually do, by the way. I've had this question too many times, even with this note in the slide. Students would come up to me after lecture like, why did we do that? You would never actually do this. You wouldn't create an object just to get rid of it on the next line. You would do something with this object instead of just throwing it away. But right now, we no longer have a reference to OX875. Nowhere on the stack do we have access, any way at all, to be able to get to this object. So it's going to be garbage collected. When something's garbage collected, we cross it off. It's no longer in memory, or at least it won't be once Java gets to garbage collecting, which might not be until the end of the program. It might not actually be garbage collected, but it's a candidate for garbage collection because we can no longer access it. So when Java sees that we can't access an object, it cleans it up for us. Just cleans up our garbage. But you would never do that. Why do we create this object? Just to have it be immediately garbage collected and do nothing with it? Well, it's so I can show you this example in lecture without having a whole bunch of stuff going on that actually justified something being garbage collected. So it would be a much bigger example. Then we're going to create another new character and assign it to a fighter variable. Now it's feeling 555 and some hot pink for our fighter. Okay, so we called the constructor 3 times. We got our objects, 2 objects left on the heap. We have 2 variables that refer to those objects. Now we're ready to do some things. Let's call hero.winBattle, which again is going to feel pretty familiar. We did this on same idea in the last lecture. Hero.winBattle. We're going to say hero. Where am I? Hero refers to 320 now. That value 875 is no longer in memory. It's like hero never even had that value stored. It completely forgot that it used to store that reference. 320 is the new reference. Win battle of 10. So this is a reference to the calling object, whatever object we were at when the method was called. And XP in the method is going to be the argument. I have this nice magic number 10. Magic numbers are bad. Oh, I shouldn't go down this tangent. But magic numbers are bad, but when you have to fit everything on a slide, sometimes I use magic numbers. Magic numbers are anytime you have a number that's not identified in any way. Like, what is 10? It's just literally the literal 10. Usually you would create a variable that stores 10, and then through the variable name, you can annotate what that value actually is. And it's a way of having self-commenting code that explains itself just with the code itself without having to add a comment. Alternatively, you could add a comment that says the 10 means this. But if you have a variable, you can have the variable name be your comment effectively. I have a magic number, which means a number that nobody has any idea where it came from. It's just made up, which is true in this case. It's just a lecture example. So XP gets 10. I already explained that. This is the value 320. And then this dot battles 1, we go over to this object. So at this point, this dot, we already resolved that part of it, and now we're at battles1 plus plus. We're at this character at the time, so we look for a variable named battles1. We find it right here, and we increment it by 1. This dot, new expression, so we start over in the stack frame again. This dot experience points equals, well, plus equals, so whatever it was, plus XP. Start again at the stack frame. XP is 10, and then reassign it that value of 0 plus 10. XP gets 10. That stack frame ends, and we're back in the main method. And notice again, that object changed. We called a method, it returns void, but it did make a change. It did affect the state of our program because it went over to the heap and made a change. So we call this method for its side effects of changing these values in the heap. Then we get to this party constructor. We're going to create a new party. Here's where things start heating up a little bit. So party equals new party. Party, got our stack frame for the constructor, our return arrow. Technically, I shouldn't have written this until after I cross out this stack frame, but when the memory diagram's done, it'll be all there. That's one thing. There is an order to everything, but when you hand in your memory diagram for your quiz, we're not going to know which order you did everything in. As long as everything's there, that's the only thing we get to grade. So it doesn't matter so much. But so we call the constructor. The constructor is going to initialize this array list of characters. And technically this did get a default value. If you're wondering, the default value for an object that should be a reference, with the exception of strings, is that true? It doesn't matter at the moment. Is going to be null. So we do have to initialize this, or else you're going to see what's called the null pointer exception, which will be a big topic on Thursday when we start talking about linked lists. We're going to get null pointer exceptions a lot. Or at least in office hours, I'll see null pointer exceptions a lot. So, and I'll show you how to avoid those. So this dot members, this is the constructor. So this is a reference to the object that's being created. We put our object on the heap and created variables for our instance variables. Any variable that's declared outside of all the methods. Battles1 is 0. That's pretty clear. But members is not going to have any value until we execute this line. This dot members equals new array list. So we're going to create a new array list. We don't have the code for array list, so we're not worried about putting that constructor on our stack with a new stack frame, even though it technically does happen. New array list. That's going to give us a new array list on the stack. Remember, array lists and hash maps are represented a little different. We use these T-charts with a big reference right on the top. So we get a new array list that resolves to a reference to the array list, and that's what we store in this dot members. So we get that value of that array list stored in members. And then we go, oh, there's my note. I was looking for this in the last lecture. This is a note that says we don't have access to the constructor, so don't worry about putting it in our memory diagrams. It's part of Java, internal to Java. I don't care about seeing it on your memory diagrams. Not quizzing you on the internal workings of an array list. Don't worry, CSE116 is going to do that plenty. They're going to make sure you understand how something like an array list works. All right, and then that returns the reference to the party variable. So we have party referring to a new party object on the heap. We're going to do party.add character of hero. So party dot add character. This is the calling object. We call add character. It takes a character, which is a type that we created, but that's perfectly legal. It's a type just like any other type in Java. And it's going to take a reference to a character. We're giving it hero, so we're giving it the reference OX320. So OX320 is what's stored in member. Member is taking a value by reference. So we get the reference 320 in member. And this is a reference to the calling object. So that's a reference to the party through which this method was called. Where does battles1 come from? So party, when we created a new party, any object that's created, when you say new something, that object is going to be created on the heap, and it's going to get a copy of every instance variable that's a part of that class. So the party class has two instance variables, members and battles1. So the party that we created gets members and battles1 as its two instance variables on the heap. Every time you create an object, it gets any instance variables, which is any variable declared outside of all the methods. So when we created our characters, we got battles1 and experience points. Every time each object got its own copy of those values, and then the party got its own copy of members and battles1. So we call add character. Add character gets two references. Every non-static method has this, which is a reference to the calling object, which is the party dot, then call the method. But hero was passed by reference. Hero resolves to OX320. Member gets the value OX320. Just like when we did P3 equals P1, we just took the value that's sitting right next to that variable and copied that to the new variable. We're doing the same thing here, except the assignment is across a method call. And this is where pass by value actually gets interesting and gets important. We would never do like P3 character. We didn't do character. Man, I already forgot. Player. With player P3 equals P1, we wouldn't do that because why not just use P1? Like we already have a variable that stores a reference to the player in question. I don't need another reference that refers to the same thing. Doesn't really make sense. But when it's across a method call, it does. Now we have a method that says, hey, I take a reference to a character, and when we're calling the method, we say, oh, here's a reference to a character. Use this one. So the assignment is across a method call using a parameter which equals an argument. That makes a bit more sense, and that's a lot more useful in our code. Now member got the value sitting next to hero, just like when it was P3 equals P1, but now it's across a method call, and we get 320 inside the stack frame. Now this stack frame has access to this party and also this character, and it can start doing more complex things. In this case, it's going to add this dot, and here's our first case of following two references in a single line. Members dot add. So we're at this array list, which by the way, we do have an indirect reference, which by the way, this array list doesn't appear anywhere on the stack, but it's not garbage collected because we can still access it through the party, which we do have on the stack. So we can still access this array list, so it does not get garbage collected, even though we don't have any direct reference to it on the stack. So this dot, looking at this line right here, this dot members dot add, we're at this array list and we're adding member, we're evaluating a new expression, so we go back to the stack frame, and member is OX320, so we're adding OX320 to the array list at 313. So when we add to an array list, it gets added to the next available index. This was an empty array list, so we get the value stored at index 0. The stack frame ends, then we do it again. We're going to add the fighter. So fighter gets the value, is stored in member, and do the same thing. This dot members dot add member. So we're adding at this array list the value 555. And we add that to our array list as well. And now we get to our interesting line. I'm skipping a little bit here because, we got 12 minutes actually. I might explain a bit here. What slide am I on? Yeah. I'll explain this. I'll slow down a little bit here because we're about to get to this beast of a line. This one's fun. Oh, man. If you can understand this line, if you get this next explanation, you're good. You're doing fantastic. If some of this is a little fuzzy, don't worry. It's it's expected that this will be, I just threw a lot of stuff at you in the last 2 hours, so it should be a little fuzzy. If it's not fuzzy, you're doing fantastic. You're above the curve. Um, if it's a little fuzzy, don't panic, but also study before the next lecture because it's only going to get deeper. Not to scare you, just make sure you're putting in your time in this course. If from now to the next lecture you're just working on task 1 and not studying this stuff, you're gonna start falling behind. Then you have a lot to study before the quiz next week, and also task 2 to do. So party that win battle of 20. Party, I can't stress enough how fast this semester is going to go. So party dot win battle. So win battle is called from this object. So this is the reference 746, and then win battle is the method that's being called. And these were, by the way, these were return type void, so we didn't have any return arrows. And I'll color code my references. I won't draw my reference arrows. Return arrows do always have to be there. That's part of the information that we're conveying. I'm conveying the same information with or without the arrow pointing here, but I need this arrow to be able to convey that information. So the return arrows have to be there unless the return type is void. Then it doesn't have to be there. So win battle, this is 746. We're passing it 20 into XP. So XP, the parameters go on the stack frame next. XP is 20. And we go through the method and execute all the code. And whenever we have a local variable being created, we'll add that to the stack frame as well. So before that, this dot battles 1. This, inside this stack frame, dot battles 1. Increment it by 1. Cross out the old value, write in the new. We hit a loop. We're creating X inside the loop. The iteration variable is always part of the loop code block. So int X equals 0. Well, X is less than this. And this we can still access. Remember, we can cross these lines. So we can still access this from within the code block because it's still in the same stack frame, whereas we could not access party, fighter, hero. We can't access any of those. And everything else is not in memory, doesn't even exist anymore. This dot members dot size. So we're at this array list at that point, and we're asking for its size. Looks to me like it has 2 elements. So size is going to return 2. This whole expression resolves to 2. X resolves to 0. So 0 less than 2, true. Execute the block. Execute the code in the code block. And then we get to this line. If you're following this line, you're doing great. Which I think most of you could read this line and figure out what it's doing. What I mean by follow it, can you follow it in terms of the memory diagram? Can you look at this memory diagram and tell me absolutely everything that happens to show me how exactly this line works? Not just that it works, not just what it does, how does it work? That's our focus in 116. So this dot members dot get of x dot win battle of xp. Let's start. This is one of those cases where I recommend just kind of toning down your brain a little bit, not overthinking it. It's easy to overthink these things, but just tone it down and take it piece by piece. That's all the machine does. The machine has 0 IQ, and it just breaks us down piece by piece and goes step by step. This dot, wish I had 2 mouse cursors. I could point to 2 things. So this dot members dot, so members dot, follow the reference. Each time you hit a dot, you're following another reference. No matter if you took a reference to get there or not, we're going to follow multiple references. So we're at this array list, and then we're going to call get x. So dot, we followed this dot, we followed this dot, we got to the array list, and then get x is called on the array list. X is a new expression, so we start back in the stack frame. We find x equals 0. So we're going to call get of 0, which is going to resolve to OX320. It's going to get the value at that index, which is itself a reference to an object. So this whole thing resolved to OX320, and then we're going to hit that with a dot operator. So we're going to follow this reference. Dot, follow the reference. So we're sitting at this character right here. And then we're going to call the win battle method of XP. So this character is calling win battle. XP is a new expression, so we go back to the stack frame. We don't find XP in the code block, but we find it outside the code block, and we're allowed to cross that line. XP resolves to 20. So we're calling the win battle method from this character, OX320, with an argument of 20. So after all of this, that's what we get down to. A new stack frame of win battle, where this is 320, because we called it from this object. And XP is 20. XP in this method is 20. And something else I forgot to mention, I purposely named these the same thing, win battle. So we have two methods, both named win battle. So which one's called when we call the method? Well, it depends on the type of the object that's calling it. If I call it through when I call it through a party, this is why we have the types in our heap. If I call it through a party, I look at the party class for win battle. If I call it through a character, I look at the character class and find win battle. So it depends on the type of the calling object. So the type determines where we look for the method, and the reference is what's going to be in this. Close. On the next iteration of the loop, it'll be 555. But since we're getting the value at 0, we got the 320. But it will be, once x increments to 1, we're going to do the same thing, but it'll be 555. So it will be, if x equals 1. Once x equals 1, we'll get it. But x starts at 0. So first we do the 320. So we did in win battle, in this win battle, we have two win battles on the stack right now, but in the active win battle, which is the one on the bottom, we're going to say this dot battles 1, increment it, this dot experience points, this dot experience points plus equals XP, increment that to 30. And then we hit the next iteration of the loop, increment x, check our condition, 1 less than 2 is true. So we're going to do the same thing again. This, in this stack frame, before this stack frame goes on the stack, this dot members dot get of 1, which resolves to OX555, and that stack frame, that's all internal to Java, so we're not worrying about the stack frame and drawing that in our memory diagram. We just know it resolves to OX555. Dot win battle. So from this character, we're going to call win battle of XP. XP is still 20, so we get another stack frame where this is 555. Increment battles 1, increase experience points by 20. Stack frame ends. The loop breaks when x equals 2, so we cross out the loop. We reach the end of the method, so we cross out the method. Then we get to the end of the main method, so the whole program ends. The whole program is removed from memory. So this line, especially being in a loop, if you can get all of that, you're doing great. You're doing fantastic. It's a lot of following references. We have a reference, which stores a reference, which stores references, and then we get to those references, we call methods, and this is always going to be a reference to whatever object called that method, and the type of each object is going to determine where we look for the method definition that's being called. Oh, there's my last slide. We got 2 minutes. I'll sit and see if there are any questions. That's it. That's classes and objects at whole. It's a lot doing that whole in 2.5 hours instead of spread across a week. Yeah, I guess I'll go back to a roadmap of the class. We just did all this stuff. That's everything you need for programming test 2. We have the programming test 1 expected deadline coming up, and then next Tuesday, a week from today, the programming test 2 expected deadline, and also our first round of quizzes. So there's a lot coming up in a week. If you haven't started, I see like half the class still hasn't made a submission for programming task 1, which might not mean I've made this mistake in the past. This sometimes false assumption that because you didn't make a submission that you haven't started. I know some of you have started but just haven't made a submission yet, and that's fair. That's fine. But half of you haven't made a submission yet. Not necessarily not half of you that didn't start, but still, I would expect at least half of you to have credit by now. But I'm also realistic, and I know that's not going to happen. Okay, there's my alarm for lecture being over. So what am I looking at? Let me just use this link to make sure I don't accidentally dox anyone. I hate going to Piazza during lecture because I always accidentally dox people. If somebody has like an anonymous follow-up and I scroll down too far right here. But I still have office hours right after lecture, so I'm going to head there. Take a quick break. Hopefully y'all have task 1 questions. If you're one of the students who have not made a submission or started, or you're stuck on something, come to me with your questions. Let's get you through task 1. If you don't come today, you're going to overwhelm Gerline tomorrow, and she might not want to be overwhelmed. Test 4 is open, yeah. I released everything. All 8 programming tests are all out there. They're all out there. The graders are up. They're in the schedule all the way through task 8. Everything's out. Everything's released. You can do all 8 of them right now if you want to read ahead. All right. The lecture's over, so I'll let y'all go. Have fun, and I'll see you in 2 days if I don't see you in office hours. Take care.